All right, today let's solve questions on resultants. So we're going to learn how to find the resultant of a vector when they are inclined at an angle 90 degrees or an angle that is less than 90 or even greater than 90. So just to help, just in case you're just learning this topic for the first time, I would like for you to, there are some topics you need to know first before you can understand everything that is going on in this question. So I would like to list out the topics. You need to be familiar with bearing, then trigonometric ratios, sine and cosine rule, and then the basic definition of resultants and resolution of vectors. Now I've done a teaching on all these videos on all these topics, so I'm going to put the videos in the description. So just click on more. You see all of them there with their links. So you just click on them and watch, because this topic is just like a building, right? It was built upon all these other things that I've mentioned, these other topics. So if you don't know these things, you have a difficulty in this one. But if you know all that, so let's continue. Now, for you to solve a question, for you to find resultants when we have vectors that are inclined at an angle to each other, you need to know what we call the parallelogram law. Now, the parallelogram law says that, I'm just going to draw a sharp parallelogram there. Now, this is a parallelogram, all right? Not the best, but it's a parallelogram. Now, the parallelogram law says that if the magnitude and direction of two vectors, all right, let me just use this. Let's say that we have a vector A and we have a vector B, all right? So if the magnitude and the direction of two vectors, in this case A and B, are represented by the size of a parallelogram, so you see that this is, okay, let me name the parallelogram ABC. A, B, C, D. So you see that the the vector A is representing the direction AB, and then they will give you the magnitude. That's why I say you should watch the video and resultant, so you understand what I mean by magnitude and direction. And the vector B is represented by the line AD. Parallelogram law says that if you have two vectors in this way, the resultant of these vectors is the diagonal of this parallelogram. Diagonal is a line that joins one end of the parallelogram to another end, which is this line. So this line is the resultant. That is the parallelogram law. So if I state it where it says that if the magnitude and direction of two vectors are represented by the adjacent sides of a parallelogram, the resultant is also represented in magnitude and direction by the diagonal of the parallelogram drawn from a common point, or the point of intersection. So that's what it means. This is just what the parallelogram law is. So knowing this is just the solution to solving every problem in this question. So whenever I have a question, the first thing to do is to complete the parallelogram. You can do that with dashed lines, but I'm just going to use a normal line to draw my own. You don't have to do this. Use dashed lines or broken lines. That's what I mean. Line that is not continuous, just to show that it was not part of the original question. But this my system does not have that kind of option, so I'm just using a whole line instead. Now, the next thing to do is, remember, resultant has both magnitude and direction, so you must specify the magnitude and the direction of the resultant. So do you notice that 3 meter? Now remember, we're talking about vectors generally. So in this question, I'm not specific on any kind of vector. Vector can be displacement, force. In this first example, since the unit is meter, let's say it's displacement. So I want to find the resultant displacement. So you discover that since we are dealing with resultants, always specify the direction. So see that this 3 Newton is in the north, this 4 meter, I'm calling Newton, I'm calling meter Newton. That's 3 meter is in the north, then the 4 meter is in the east. So the resultant is definitely going to be in the northeast direction. Alright, so that will be the resultant. So let's draw that. The resultant will be from the common point. Remember, from parallelogram law, this point, this will be the resultant in the northeast direction. Please, in resultant, it's very important to specify the direction. So you say the resultant is in the northeast direction. Now, there are two things that you'll be required to find when you're asked to find the resultant. Number one is the magnitude of the resultant. And the magnitude of the resultant is, we can call it R, which we are going to look for. Another thing you're expected to find is the direction of the resultant. Now, there are two ways of representing the direction of the resultant. I'm still going to go into all that. But the first one is the direction the resultant makes with the horizontal, which is this angle there. So that will be our angle, or rather the direction of the resultant. This is the angle it makes with the horizontal. And then if I want to represent it in bearing, we're also going to learn that. But let's just take it one step at a time. Now, before I proceed, the last thing I need to tell you is that given a parallelogram again, there are things you need to know to help you solve. First thing is that know that opposite angles are equal. All right, so we have angles here, we have angle here. Now, opposite angles are equal, meaning this angle is equal to this angle, provided that this is a parallelogram. This angle and this angle are equal, and then these other two angles, let me use another color for that. This angle is also equal to this angle. That's one thing you must know. And then another thing you must know to make the thing easy for you, let's name the angles A, B, C, and D. Another thing you must know is that angle A plus angle C will be equal to 180. Alright, and then angle D plus angle B is equal to 180. They are not equal, but they are supplementary, meaning if you sum them together, you get 180. So if you know this, it's going to help, you in solving many of these questions. So finally, now let's start solving. Okay. Now we're looking for this resultant. Now, from what we know, remember that opposite sides are equal. So, and since this is a right angle, this also, we are going to say that this side is also a right angle. That's very simple, right? Because this place is also a right angle. Yeah, it's also a right angle. So opposite angles must be equal. So this is a right angle. So let's work with triangle A, B, C. So you see that we have a right angle triangle there, and opposite sides are also equal. So if this is 3 meters, this side will also be 3 meters, this side will also be 4 meters. So these are the things you must know. You must know these things. Now let's solve. You see that the resultant is the hypotenuse, so we can use the Pythagoras theorem. Pythagoras theorem. So anytime it's a right angle triangle, always remember to use the Pythagoras theorem that says that c squared is equal to a squared plus b squared. Now let's do that. The resultant now is the c, which is r. So just say r squared is equal to a. We can use any side as a. Let's say 3 squared plus 4 squared. So r squared is equal to 3 squared is 3 times 3, 9. 4 squared is 16. So r squared is equal to 9 plus 16 is 25. So r now we take the square root of both sides. So we have r to be equal to the square root of 25, which is equal to 5 meters. So this is the magnitude. Please take note. What we just found is the magnitude of the resultant is 5 meters. All right. Now, what is the direction? The direction of the resultant is, remember, we're saying that is this angle. Let's call it theta. So let's say this is the direction the resultant makes with the horizontal. Now, this is not the direction in using bearing, all right? This is just the direction it makes with the horizontal. Most times in a question, if they do not specify, you can just use that one as your answer. So that would be the direction. So let's find that angle theta. See that we can use SOHCAHTOA because this is a right angle triangle. So we can always use Pythagoras theorem and SOHCAHTOA. So using the SOHCAHTOA, that's our trig ratios basically. So you see that we have, let's just work with this angle. We have this angle, this side rather, and this side. We also have the resultant because we found the resultant as 5. So you can use basically all the trig ratios. It's going to work. But let's just work with those two sides. So you see that this side is the opposite side because it's facing the angle. Y4 is the adjacent. So we're going to use tan. We're going to say that tan theta is equal to the opposite side over the adjacent side. Now you can also use sine. So I will advise you to, maybe after using the tan, you can personally use the sine and the cosine and also see whether you get the same answer. Take that upon yourself and do it. Now the opposite side is what? 3, while the adjacent side is 4. So we have tan theta to be equal to 3 over 4. That's what we have now. So remember, our emphasis is on theta. So to get theta now, we just need to find the arctan or the tan inverse. So theta will be equal to the tan inverse of 3 over 4. So let's plug that into our calculator. So theta is the tan inverse of 3 over 4. Alright, so let us approximate to 2 decimal places. We have 36.87 degrees. So this is the angle the resultant makes with the horizontal. Please don't forget, this is the angle the resultant makes with the horizontal. However, if you wanted to if we wanted to describe the direction of the resultant using bearing, maybe the compass method. Now let me just draw a cardinal point there. All right, so you see that this is the east and this is the 4 meter, right? So this is the east. You see that this resultant is going in the northeast direction from what we have drawn, because this is the north. And now we have found this angle, because the angle it makes with the horizontal, which is the angle it makes with the east. We have found it now to be 36.87 degrees. That's what we have found now. Now the angle it makes with the north. Remember, if you want to represent angle using the bearing, you're going to check the angle it makes with the north, turning in the clockwise direction. So that would be this angle. So this angle is what we are interested in, right? That will be the angle we're going to use. So you know that from north to east is 90 degrees. So generally, anytime you have a question like this, once you have found the angle it makes with the horizontal, subtract it from 90 degrees to find the actual angle, using the bearing method. So the angle the resultant makes is 90 minus 36.87. 90 minus 36.87 is going to give us 53.13 degrees. Right, so that's what we have. Now, representing it in compass method, you see that the angle is between north and east. So I'm going to say is, okay, I think I'll just represent it down there. So the direction of our resultant is north, 53.13 degrees east. So this is the direction. Now, let's go through our answers again. Now, first of all, what is the magnitude of the resultant? The magnitude of the resultant is 5 meter, which is our answer here. So this is the magnitude of the resultant, the magnitude, the size of the resultant. Now, what is this answer? This answer is the direction or the angle the resultant makes with the horizontal. Please don't confuse any of the two. This is the angle the resultant makes with the horizontal. Then this is describing the direction of the resultant using the compass method in bearing. All right, so whenever you're asked to solve for the magnitude and the direction of a resultant vector, this is the magnitude, and you can use, I always prefer this one for the direction, but you can as well use this one. All right, I'm just going to specify that the angle it makes with the horizontal. All right, so know the three of them, and then it's better you know everything, and then you're familiar with the concept, and then you can deliver whenever you're asked to. So that is it for this question. I hope it's clear enough. So let's move over to the next one.